In this video, we are going to explain about the project title Predicting Student Performance with Deep Neural Networks. In recent years, the use of internet based educational tools has grown rapidly. These tools provide a clear advantage for students and teachers alike with the ability to access and share course data from anywhere in the world, track student progress, and provide rich educational context. Academic students' performance has always been a major factor in determining a student's career and the prestige of the institutions. Education data mining is a discipline which is followed to extract meaningful knowledge from an educational context. Educational data mining applications such as model development helps to predict student performance in their academics. The main objective of this project is to predict student performance based upon the various machine learning algorithms and neural networks, such as KNN algorithm, Navi bias, support vector machine, logistic regression, random forest, and decision tree. Hardware requirements, we need operating system Windows, processor i5 and above, RAM 4 GB and above, hard disk 20 GB and above. Coming to the software requirements, we need to install Python with the version of 3.7. Methodologies. To implement this project, we have introduced few modules that are first one upload student performance dataset. By this module we are going to upload the dataset to this application. Second one pre-processing and dataset transmission. In this module we are going to clean missing values and then convert all dataset non-numerical values to numerical by using data transformation. In the dataset, for example, gender, we have values as M and F, but machine learning algorithm will not understand non-numerical dataset, so we have converted it into numerical values after the data transformation. M will be replaced with the value 0 and F will be replaced with the value 1. For all non-numerical values, data transformation will be applied to convert to numerical found. The next format, that is split the dataset into train and test model. In this module, we will split the dataset into train and test records. Application will be used 80% of data for training and 20% of data for testing. Next module, run KNN algorithm. In this module, we are going to train the algorithm and build the KNN algorithm by using training dataset, and by using testing dataset, we are going to calculate the accuracy. The next module, run Navi bias algorithm. In this module, we are going to build the algorithm and then calculate the accuracy, precision, recall score based upon the test model dataset. Navi bias is a algorithm which is one of the most commonly used algorithm for classifying problems. Is a simple probabilistic classifier and is based on Bayes theorem. It determines the probability of each features occurring in each class and returns the outcome with the high probability. The next one, run decision tree algorithm. In this module, we are going to upload the training data set to the decision tree algorithm and train the model and build it, and then test the algorithm with the test model decision tree algorithm to predict and calculate the accuracy score. The next module, then logistic regression algorithm. In this module, we are going to build the algorithm logistic model and also train the algorithm with the trained dataset, and then test the algorithm with test dataset, then predict the output has accuracy. Then run random forest algorithm. In this module, we are going to train up the algorithm and build the algorithm Then test the dataset with the random forest algorithm to calculate the accuracy. The next module runs support vector machine algorithm. This support machine learning algorithm involves predicting and classifying data, and to do so we employ various machine learning algorithms according to the dataset. Support vector machine is a linear model for classification and regression problems. It can solve linear and nonlinear problems and work well for many practical problems. The idea of support vector machine is simple. The algorithm creates a line or a hyperplane which separates the data into the classes. In machine learning, the radial basis function kernel or RBF kernel is popularly kernel function used in various kernelized learning algorithms. In practical, it is commonly used in support vector machine classification. So, run support vector machine algorithm model will build the support vector machine model and test it with the testing data set and get the calculated of accuracy. The next module, that is run neural network algorithm. In this model, we are going to build the neural network algorithm with the trained dataset, and with the test dataset, we are going to calculate the accuracy by the prediction of different layers of the dense layers, dropouts, and multiple layers in the neural network algorithm. Next module, accuracy comparison graph. In this module, we are going to plot the graphical representation of accuracy based upon the different algorithms which we have used in this project. Next module, last module, upload and predict a new student performance. In this module, we are going to upload the test data to the highest performance accuracy scored algorithm and predict the new student performance based upon the test data. Now, go to the execution, close this file and go to the code file. This is the code file consists of dataset file. This is the trained data and test data files in the dataset file, and this is the main code file, and this is the transformed file which are used to transform the numericals non-numericals into the numericals format are stored in this excel sheet. And this is run bat file. This run bat file, instead of executing program into command line interface, we created Windows bat file to execute the project. By clicking double tap on it, it leads to the graphical user interface which is interactive to the program user. Now click on the first button, Upload Student Performance Dataset. By clicking this button, it can show the dialog box open and select the dataset and click on open. Now you can see that dataset is loaded. The next button, click pre-processing and data transformation. By clicking this button, you can see the data transformation which was transformed the data, whatever the non-numericals, missing values and etc., all into the numerical data for the understandability of the machine learning algorithms. Then next button, click on the split dataset into train and test model. By clicking this button in the back console, you can see the division of training and testing model samples, and here you can see the samples of the records of whole data set was divided into 80 percentage of data and 20 percentage of data application. Now click on the run KNN algorithm. By clicking this button, you can see the accuracy score of KNN algorithm. The next button, run random Navi bias algorithm. By clicking this button, you can see the graphical representation. Mummy ఏం చేస్తుంది?